Hello, my dear friends. How you all are doing today? I hope you are having a great time. So, friends, today we are going to discuss a very interesting topic that is on Internet Protocol IPv4 and IPv6. I hope you might have heard about this different protocols like IP protocol, HTTP, TCP, IP. Okay, so IP stands for Internet Protocol. Okay, and what we are going to do in today's video is we are going to have a deep dive of, or basically we are going to touch base both the IPv4 and IPv6 and what are the differences and why there is need to switch to the IPv6. Okay, so that we are going to see. So this is a theoretical session. In the upcoming session, we will do the hands-on lab associated with the IPv6. Okay, I hope this is very clear. Now, as you can see on my screen, this is the PPT that I am going to share with you guys today. First of all, let's see what will be the agenda of today's session. As I mentioned earlier, we will initially see what is IPv4 and IPv6 and why there is a need for IPv6. Okay. Then we can have a discussion around the major differences between both, that is IPv4 and IPv6. Then after this, we will understand what is the format of IPv6 in detail, and then we will see how will we transition from the existing, that is IPv4 to IPv6. Okay, so that will be the agenda of today's session. Now let's, without wasting our time, let's get started with the discussion. So very first thing is, what is this IPv4 and IPv6? So basically, the IPv4 and IPv6 are the two different version of internet protocols. So see, we normally, so the IPv4 is being used commonly. Okay, so everywhere the IPv4 is being used, and there is a need from there is a need to switch from IPv4 to IPv6. Okay, so why there is a need, you will say, because see, IPv4 is basically 32-bit IP addresses. Okay, so there is some limitation in terms of the capacity. It can generate around 4.3 billions of IP addresses, and that is not sufficient. So it could be sufficient at present, but in foreseeing future, so it is not, that is not sufficient. Hence, there is a requirement or need that we need to switch from IPv4 to IPv6 in the near future. Hence, nowadays there's, we are being used, so it's not like we will completely shift from IPv4 to IPv6. We will see the transition part of that. It's like at present both are being used, but in future IPv6 will be required because of this, the limitations with the IPv4. I hope this is very clear. IPv4 is more advanced version of IPv4. Okay, and it's designed to address the limitation of IPv4, solves the issues of running out of IP address, as just we discussed. That is a limitation. Now we will see what is the differences, key differences between both of them. Address space, address format, security, header structure, and other features. So these are some of the key differences that we are going to deeply discuss in the next slides. Now let's discuss the differences. The first is very important, is address space, that is size. Okay, v4, like IPv4, it uses 32-bit addresses and limiting it to about 4.3 billion unique addresses, whereas v6, so here the major difference. So v6, when we go for the version 6, okay, it utilizes 128 bit of addresses and providing virtually infinite pool of addresses for foreseeable future. So you can say it's just infinite. So if we compare with 4, version 4 and version 6, so version 6 is definitely is something that is infinite. Okay, the vast address space of in v6 solves the issues of running out of IP addresses that was becoming a concern with IPv4. Okay, so right now you will say, okay, if that is the issue, okay, right now as we are normally being used IPv4, so how the addresses are being used. So this is this is normally, say, if you have mostly in the organization, what is being done is we are using mainly private IP addresses. Like, see, our devices are having, say you are using the devices inside our organization, so those are having private IP addresses normally. And for a group of IP addresses, say we have 10 or 12 or 15 or whatever the IP addresses, there will be one public IP address that will be netted, okay, or that will be, for address translation. So the lots of private IP address will correspond to one public IP address in this in the current scenario. That is the way, this is, you can say, a kind of a workaround in today's scenario. But that is not a going to be solution. Hence, there is a need to switch from IPv4 to IPv6, or to use combination of both. That also can be used. So we'll see in the detail. The second difference that we can see is address format. So I hope you might be aware, or if you're not aware, see IPv4 as it is 32 bits. So the addresses are written in dot decimal. So it is in the dot decimal format. For example, it's a 172.168.0.5. So this is, you can say, 32-bit addresses. Okay. However, IPv6 is 128 bit of addresses. So it is, it's an 8 group of 4 hexadecimal digits. So it's represented by colons. Something like this, say FE80. Okay, so this can be say as an example of IPv6. And IPv6 addresses are from 00 to FF. So in the hands-on lab, we'll see how that can be switched from 00 to FF for the subnet of the VPC that we can see. So basically, V4 is in the dot decimal notation. Okay. However, V6 is in the hexadecimal digits. Okay. So it is 128 bits long. Now, in terms of security, again, version 6, that is IPv6, has upper hand. So IPv6 incorporates security features like IP security, IPsec direct into protocol, where when we have V4, that the existing one, we need to rely on the add-on solutions for the security. So that is another difference between both. We have some more differences in terms of header structure as well as other features. Okay, header structure is IPv4 has simpler and more efficient header structure. Okay, and because of that, because of the simpler header structure, this improve the routing efficiency and potentially lead to faster internet speeds. So that is the another important difference between both. And we have some couple of additional features for V6, something like which are not present in IPv4, such as built-in quality for quality of service QoS and simplified network configuration. So with IPv6, we are having these, you can say, benefits or features with that. Now let's understand in detail what is the format of IPv6. So as we had covered in the previous slide, the size of IPv6 is 128 bits, which is compared to 32 bits in the V4. Because of this, there's V6 is having lots of capability to provide us the IP addresses. That is the very important about V6. The format, it's 8 16-bit groups, and it represents hexadecimal values separated by colons. Okay, so this is example you can see. Okay, so we can have the example like that in case of IPv6. Shorthand notation. So if when we have leading zeros within the group, so that can be omitted. Okay, so this is an example, you can see it becomes like this. If we have double colon, so in the IPv6, if you see there's double colon, so it can be something, it represents a series of zero groups. So if we have series of zero, now you can see it's 2001 TP8. Okay, and there is a double colon here and 3333. So this double colon space that represents a series of zero group. So if we have a series of zero group, that can be represented like this. Okay. Another thing is embedded IPv4 format. Okay, so we can combine both. So IPv6 and V4 for compatibility in the mixed environment. Okay, so here just to give an example is colon colon 192.168.17.5. So by the these four fields itself, you'll understand this is IPv4. Okay, and the initial one, that is 96 bits, represents IPv6. Okay, so we can have the embedding IPv4 format as well, like this one. Now when we have a requirement now, like in maybe in the future, as we need to switch to the IPv6, so we need to start thinking on the transitioning from IPv4 to IPv6. But a very important step in this regard is due to some backward compatibility issues. Okay, so it's not like we can directly switch from IPv4 to IPv6, and that needs to be done in a gradual manner. It's we cannot do it directly. Okay, because of this, some of the issues lies backward compatibility. This is one of the issues. Issues you can say are major challenges. Transition, but we can adopt some of the strategies so that we can have some smooth transition. So the transitions can we can use with respect to these are some of the strategies like dual stack routers, tunneling, and header translation. Okay, now let's discuss each of this strategy for transitioning from IPv4 to VCs in detail. First one, dual stack routers. So as the name suggests, so these are basically specially designed routers. Okay, so these routers enables the traffic for both. Like we can have a single router that will accommodate both IPv4 and V6, and the devices connected with these routers can communicate using either version. So because of that, this is a kind of, you can say, a way that we can use both V4 as well as V6. Tunneling is another way in which say IPv6 packets from IPv4 are extracted. So this is in the tunneling method. And lastly, there's another technique that you can say that is called as header translation. So this technique utilizes a device that translates IPv6 headers into IPv4 for communication with the older system. Say if you have in a scenario like you have systems, many systems with IPv6 addresses, but there are some other or old systems which are still using v4, that is version 4. In that case, we can use the header translation, and because of this technique, what it does is it will translate. It uses a device that translates v6 headers to v4 or communication with the older system. Because the older systems might be having IPv4, and because of that, we can use this technique. So, friends, that's it for today. Let me just quickly summarize what we discussed so far. So, we discussed today what is IPv4 and IPv6. Basically, both of these are internet protocols. When the version 4 has a limitation of 4.3 billions of addresses that can accommodate current requirement, but considering the futures requirement and see the we know in these days everything is we are having the many of the things, so that's world is moving fast. We have internet, IoT, or AI, ML. So there will be in future we can have this current IPv4 pool won't be sufficient for providing the IP addresses to those devices, and because of this requirement there's a need to switch to version 6. Okay, so the differences between both are in terms of address space, format is different, whereas v4 when we use 32 bits, whereas in v6 we need to use 128 bits of address. Security, v6 being advanced one as having some additional feature like IP security, whereas with the version 4 we need to rely on an add-on solution. There is not inbuilt solution with the version 4. Header structure as well different for both because of v6 and its simpler header structure. It it's gets upper hand in terms of smooth routing and efficiency. We also have some other features as well. Other features in terms of V6 provides some features like built-in support for quality of service and simplified network configuration, which are not there in the V4. Then we detail in the discuss in detail about what is the format of version 6. You can see these are some of the things with related to the format, and we also covered what is how you will transition from v4 to v6. So transitioning from version 4 to version 6 directly is not possible because of the challenges like backward compatibility. This needs to be done in a step by step way. However, we can use some of the strategies like dual stack router, wherein it uses a specially designed router that communicates in a both v4 as well as v6. Tunneling is another way. Yeah, this is the method where v6 packets are extracted from v4. And lastly, the another technique is headers translation, where in case if we have older systems communicating with version 4, so in that case we can use a device that translates version 6 headers to version 4 for communication with the older system. So friends, that's it for today. I wanted to cover this quickly because I thought this is very important. And as I mentioned earlier in the slide, the next session would be a hands-on lab where we will configure a VPC, and we will configure it accordingly IPv6 and subnet as well, and we will try to communicate the EC2 instances according to that one. So that's it for today, friends. Thank you so much for your time and take care.